Java 8 update to language introduced a couple of interesting features, including lambda expressions and streams. Lambda expressions we have already discussed in the previous examples. Now let's talk about the streams or stream API as we call it. A new abstraction of certain functionalities related to data operations that introduced in Java 8. If you have worked with the earlier versions of Java, you can get a bit confused by hearing the word stream because we have done a lot of input output stream operations earlier too. And one can ask what's the difference between a stream API and an input output stream in general. To understand that, we need to first look at the meaning of the word stream in computer science itself. A very basic definition of a stream in our domain is that it's a sequence of data elements made available over time. So when we use java.io package and its input output streams or error stream classes, we perform input output operations. That is reading data from an input source, which can be a file or a keyboard, and displaying or writing it to an output destination, say files or command prompt screen. But the Stream API introduced in Java 8 are for a different purpose. Their work is to perform some aggregate operations on that data. And to perform those operations, Java 8 has expanded the meaning of source for streams too. Now, the source for a stream can include not just input output resources, but arrays and collections as well. And in that context, a very quick definition of streams in Java 8 is that it's a sequence of elements from a source. That source can be IO resource, can be collection, can be an array that supports aggregate operations. There are three important words in this definition. The first is sequence of elements or sequence of data elements, we can say. It is important to know that streams does not actually store these elements. They are not the data collections for those elements. These elements are computed on demand. The second is source. And as we have already discussed, stream can consume data providing sources like collections, array, or even the IO resources. And the third one is aggregate operations. A stream supports SQL like operations and common operations from functional programming languages like filter, map, reduce, find, match, sorted, and so on. Now, one can ask, we can perform similar kind of aggregate operations on collections as well. So, what's the difference? There are two important characteristics of stream operations that make them different from the collections. One is pipelining. Many stream operations return a stream themselves, and that allow us to do some operation on that returned stream, and that makes a kind of chain of operations, and we can say we can form a larger pipeline of the operations with the help of streams. And this pipelining help us to optimize our stream. Each time you're optimizing your stream to a better outcome. Another is internal iteration. In contrast to collection, where we used to get an iterator and then iterate over the value explicitly, here we have an internal iterator at work behind the scene working for you. So, in a nutshell, we can say streams in Java 8 provide a functional programming approach to processing collections of data and a simple and efficient way to perform complex operations on collections of data. So, some key features of streams in Java 8 are: the first is a stream is a pipeline of operations that can be executed on a collection of data. So, as we have discussed, we can create a whole larger pipeline because each time in intermediate operation, you will get a new stream and you can perform certain operation on that. Streams can be sequential or parallel because they are designed to work on the multi-core CPUs. Streams can be created from various sources like arrays, collections, or I/O channels. Stream operations we generally divide into two categories: intermediate and terminal. Intermediate operations are those that you are performing in the processing stage. And once the process is done, you finally get the output. And when you get the output, that is called the terminal operation. So, terminal operation is the final operation that you perform on a stream to produce a result. Intermediate operations are those that transform or filter the data in your stream, like when we call the filter function or the map function or a flat map function. And terminals are those that produce a final result, or we can say a side effect of your stream operations, like for each, collect, or reduce. So, streams are generally called the lazy because they do not start processing the data until a terminal operation is called. And they do not start processing until the user asks for it. So, it's not that the data is available to you whether you ask for it or not. Streams are lazy because they will only produce the data on demand. So, to summarize the Streams API in Java 8, we can say that streams in Java 8 let us write code that is declarative, means more concise and readable, a code that is composable, so we have greater flexibility in our hand, and a code which is parallelizable, so that it can perform better on your multi-core CPU. Now, how streams are often compared with the collections? What are the comparing points between these two different structures? And how streams are different from the IO streams as well. We'll talk about that in the next part.